So it's my pleasure to introduce Chris Wagamot. So Chris is Senior Product Manager for Commercial and Residential Lighting at the Northwest Energy Efficiency Alliance. So Chris has had a little over 23 years of experience working in utility work as a program manager, energy efficiency engineer, and a product manager. Now, the cool part about this today that we are very privileged to be here is that Chris was kind of, if you think about, okay, a baby is born. So Chris was there at the, whenever the Luminaire level lighting control started. He was one of the founding groups in the Northwest where all of this started. He watched the baby grow to a child, provided guidance, grew along with it, and now we have a full-fledged adult. And so we have a fully mature technology. And so Chris is going to tell us about that. He's done some studies that he's going to cover. And so Chris, so pleased to have you today. Welcome to Raleigh, North Carolina. Take it away.
Well, thank you, Bob. Thank you, Christine. I'm very excited to talk about luminaire level lighting controls, talk about a couple of reports that we've got done over the last year. It's been a very trying year, but it's been a great year for knowledge, learning, and we've got some great stuff to put out there. So let's dive right in and get into it. So the first slide is just sort of some learning objectives. So for those that know the difference between an LLC and an NLC, so basically that's luminaire level lighting controls and network lighting controls. Why I feel like LLC is the future of lighting controls. Why I think that they're the best option moving forward. And understanding the energy savings potentials for not just LLC, but the NLC products as well, which are quite great. So those are what we hope that you get out of this at the end, and we'll see if we succeed. So next slide. So here's the agenda. Just real quick, we're gonna just kind of run through an introduction on LLC and NLC, and talk about the methodology in one of our reports and the findings, go into the next report and go through its design and results, and then hopefully have time in the end for some questions. So next slide. The first thing I'm going to do is kind of tell you, I would assume that most of you guys don't know who NEEA is, Northwest Energy Efficiency Alliance. And so we're an organization that's been around for quite some time in the Northwest. We're funded by all the local utilities, so in Oregon, Washington, Idaho, and Montana. And we define ourselves as a market transformation company. So what that means is we're a little different. We don't run programs for utilities. We don't run incentive programs. We don't do any of that kind of stuff. But our goal is to find products that are in the market that may not be market available or you know, a big draw, but they're very energy efficient. They're at the cutting edge. And our goal is to bring those products to market faster so that we get the energy savings from them. So we work in all sorts of things, from lighting to heat pump water heaters to HVAC to motors to televisions and consumer products. And you know, like I said, we're funded by the utilities in the Northwest. So we have a really nice base, and I've been doing this for probably, let's see, almost 28 years. So a long time. So we've been at this a while. Next slide. So we're gonna go through the introduction real quick. Next slide. And so we're gonna start off by just sort of giving a definition. So this is the definition of an NLC, so a network lighting control. This comes from the DesignLights Consortium, the DLC. This is their definition of what a network lighting control is. The network lighting control system consists of an intelligent network of individual addressable luminaires and control devices, allowing for application of multiple control strategies, programmability, building or enterprise level control, zoning, rezoning, using software, and measuring and monitoring. That's a pretty long statement. For the gist of this is that this is the sort of the newest in controls when it comes to what the same model of controls have been around for a long time. You're just using, in some cases, wireless, some cases wired, but you're taking it down to a little more granularity than what used to be when you had controls where you had a room and you had a single sensor that controlled multiple fixtures. This is giving a little more smarts to the fixtures to have them be able to do some stuff that's, whether it's dimming or controlling them or, getting energy monitoring from the fixtures down to the individual fixture level. So if you go to the next slide, we'll define LLC. And so this is kind of an interesting thing. So LLC is a subset of NLC. So it has all the functionalities of the NLC of network lighting controls, but more, it's just a subset. So in the scope of thing, all LLCs are network lighting controls, but not all network lighting controls are luminaire level lighting controls. So maybe that'll be a little confusing, but the main gist is if you think of it as an umbrella, LLC is underneath that umbrella, and then there's a lot of different options. So what makes LLC different? So LLC consists of an LED lighting system with one or more luminaires with an integrated occupancy and daylight sensor on each luminaire and embedded lighting control logic and wireless networking capabilities. So this definition comes from a code. It is the IECC 2018 and a new one that'll be coming out 2021 of luminaire level lighting controls is written into the code as an optional path, and this is what they define it as. The main gist of this is that luminaire level lighting controls is set up so that, like in this little picture, there's a sensor in the fixture, and what it does is it gives you that granularity to have every fixture become smart. So the end node of your power, the fixture itself, is now a smart fixture and is capable of everything, regardless of whatever any of the other fixtures do. That one fixture can be programmed independently. But what it doesn't mean is that that fixture is controlled by an individual, right? That's obviously a path this could go down, but it's not necessarily that you're giving the person underneath that light control of the light above them. What we're just saying is that that fixture is independent and capable of being controlled individually, or you could define each fixture to do what you want it to do in the programming to, have a higher light level or a lower light level, or in some cases a different color based on every zone. So next slide. So what are the benefits of luminaire level lighting controls? So the ones on the left of this slide are things that all of them have. This is the base requirement. So they all have occupancy sensing, they all have continuous dimming, they all have daylighting, they all have high-end trim task tuning, and they all have controls persistence. So the two that probably trip most people up are the high-end trim and the controls persistence. So I'm going to talk about those real quick. I think most people understand occupancy and daylighting. So high-end trim is the ability for every fixture or every group or every zone to set the max power that that fixture is going to go to if it goes to full on. So in an LED fixture, you can say that if it's 100% on, it's got 100% power, you're changing the wattage that's going in and it's reducing the light level at the same time. So if I say I'm dimming it at 50%, obviously you're using about 50% of the power with LEDs. So what the high-end trim does is you can set that number at whatever it is. Typically it's around 80%. That when that fixture says, I want my power to be fully on, it doesn't go to 100% power, it only goes to 80% power, which is a huge energy saver for utilities and for the building itself. But the big thing is that in most cases, and we'll get to see this inside in the reports that are there, that most cases, LED lights are much too bright out of the box at 100%. Most people are dimming them or setting the trim as every time we do it. So this is a great place to be able to cap that, to make sure that it's set in a place that the occupant is comfortable with the light level and the energy level is reduced. So now the last one is controls persistence. That one is a function of LLC that basically says each of the fixtures are capable of reverting to an energy saving mode if it loses connectivity with any other device in the group. So some of these do, a mesh network where they talk to all the fixtures around them. Some of them talk to a router or a hub. And if they lose connectivity, they don't revert to a non-energy efficient mode, such as just all on or all off or 100% or whatever. They'll revert back to whatever the last energy efficient mode that was programmed into it. It'll continue to operate in that mode, even if it's losing connectivity. So that's important, especially when we're talking wireless, because there's always times when the connectivity becomes an issue, or if the system doesn't boot right or whatever. This allows for you to continue in the same energy savings mode that it was programmed with to begin with. So those are all required in every system. The ones on the right are sort of the benefits that come with LLC that are not energy benefits, but they're customer benefits. We call them non-energy benefits. But these things allow for these systems to be so valuable to the customer. You can use the sensors that are in every fixture for asset tracking, plug load, occupancy, space use utilization, and all the systems should be demand response capable. So some of these are more important. The other thing that we're seeing now in the last probably 2 years is the integration of using the lights to control other building systems, such as HVAC systems or window blinds or security or stuff of that nature, because when you have a sensor that's spread throughout the main floor of the space in every fixture, you have the granularity of that to be able to see much more detail than in previous systems. And now you can do all of this stuff. The asset tracking is huge for, like, say, retail. Target uses this, where they can track your phone when you come in and send you a coupon if you're standing in front of the tomato sauce for spaghetti noodles, right? Or they can see which end caps are getting the most, attention because people are standing there, stopping, or whatever. That goes along with the space utilization for an office. You can be able to track how the office is used and see if there's and see that there's one conference room that's not being used and one that's being used a lot, and then you can figure out how to shift that so that it it's a better flow in the space. Over the last course of the year, part of that is also working for a healthier building, which could be defined with what the contact tracing. So you can use these systems to define if you only want 50% of the occupancy in a space, you can limit down and it'll set warnings and do some of that with some of these systems. Not all systems do this, but this is a thing that's starting to definitely make its way into these systems, is some sort of quote unquote contact tracing for optimizing the space and keeping the space limited so that you're not overcrowding in the space. All right, let's go to the next slide. So the first report I want to talk about is an energy savings report that has been done twice. So the first one was done by the DLC in 2017. And then NEEA and the DLC redid it this last year, so 2020. It's about a year-long process to do this report because we've got to get the data, work through everything. So a lot of things that happened, and the reason we did this again after the 3-year mark was we increased the number of manufacturers of the products. We increased the size and the number of buildings that we looked at. We added a building type that we didn't have before. And this time we were able to analyze the effect of high-end trim versus the other control strategies. So this is kind of an interesting thing because it shows how much trim work is being done when you're using these type of systems. So let's kind of just jump right in and talk about it. The next slide is the finding that is pretty consistent with the last one. I think the first study came in right around 49% energy savings for all network lighting control products. And that came in again this time. Network lighting control products came in at a 49% savings. So that's the big takeaway for the network lighting thing. The other thing this report did, and we'll get into it here in just a little bit, is it was able to break out the LLC product and its savings numbers separate from the network lighting control product, which in the first report was not something that was capable. There just wasn't enough of the LLC at that time to break it out in a statistically valid way. But this time there was. All right, let's go to the next slide. I think we'll go through sort of the methodologies and the results. So, next slide. All right, so probably the biggest, amount of work, and when we did this, we hired Energy Solutions to do the work for us, was the data collection. So we did a ton of outreach to organizations, from manufacturers to utilities to research organizations to end customers, to try to get as much data as we possibly could out there so that we had a good foundation. We already had the foundation from the first report, so we already had a good set of numbers and continuing data from them, and this allowed us to get some more data. So this is sort of the process of this initial outreach, detailed follow-up, and data transfer. Over the course of this, for this report, we got 8 contributors from manufacturers to utilities to end-use customers and research organizations. Like I said, the greatest challenge is the access to the data, and some of these people don't. Some people don't keep the data over time. And we wanted more than just a snapshot. We wanted as much data over time as we could, so that we could look at it. Next slide. So this gives you an idea of kind of what we looked at and where we saw the most buildings and where the information was. So, the ones that had the most options in different manufacturers were manufacturing, office, retail, education, warehouse. And those are the big ones, really. The other ones, assembly, restaurant, and healthcare, we got to see some of the stuff. It was nice to see what was going on there, but the main look was at the top 5. So we ended up with 194 buildings, 8 building types, and 12 manufacturers. Next slide. Where do we get all that stuff from? We basically covered most of North America. We had 35 U.S. states, 5 states in 5 Canadian provinces, and Mexico. So we got a pretty good, well-rounded look at where these products were getting installed. And as you can see, of the sample size, they're installed in quite a few places. This is just the ones that we're able to get data off of, and that doesn't count for what the actual installs are going in. So, next slide. So part of this is normalizing the data. One of the unfortunate things with all this is that the data that we get from everybody is not universal, and then not in a universal format. It's all in a unique data format. So we had to take all that data and normalize it so that it would present the same information across, when we looked at it. So we weren't looking at apples and oranges, that we were looking at, apples to apples type of thing. So we had to go through, and this took a lot of time and effort. The fortunate thing is that a lot of the programs that we had to do, we had done in the first study, so this carryover wasn't nearly as difficult because a lot of the formats were in new, and we had a way to normalize them. All right, next slide. Okay, so how do we attribute the savings? So this is a pretty typical power usage of what we saw and how we we looked at it. So we knew what the max luminaire output was. So that's what the maximum lighting output was. And the highest output level observed is, you know, just tracking it to see that we knew that there was a difference. I think if you click one, you can probably click twice and it'll pop up a couple arrows. So that that space between max luminaire and highest output is the high-end trim. That's what we defined as high-end trim. And then once you hit next once on the slides, yeah, one more time. Yeah, okay. So that top part there is what we contribute to high-end trim. All the other savings that's noted in there is from the other control strategies. So, and then we defined a occupied threshold, you know, a 10% max power hour. So this is how we came up with the savings and how we defined the savings. The one thing I'll note, and it'll be more evident when we look at a few slides in on the energy savings numbers, is that the two savings percentages that we come up with, so one for high-end trim and one for the other control strategies, are not additive. And what I mean by that is that in this case, let's say in this case, it's 20% of the savings comes from high-end trim. You don't add the 20% to that and then the others to come up with the number, because high-end trim is a set number. But if I took away the high-end trim, I would still have the same percentage of savings from the other control strategies that's there, right? So we look at the control strategies that are the occupancy and daylighting as if there's no high-end trim, because you would have that percentage, you'd have a percentage based on saving all that extra in the trim as well, if you were using just those two strategies, right? So they're not additive when you look at them. And that'll become clear here in just a little bit. Next slide. All right, so, you know, again, we saw this, the average control factor for across all building types and all network lighting systems was 49%, which is a pretty decent savings. And this does not account for anything that's the fixture savings. This is strictly the control savings. Nothing to do with savings going from a fluorescent fixture to an LED fixture or any of that savings as well. This is strictly the savings for the LED fixtures or the new fixtures that are in place. Next one. So how did we look at this? So one of the things we did was we looked at the 25 percentile to the 75 percentile numbers, and we threw out the top 25 and the bottom 25 as outliers. So this whisker chart kind of gives you an idea of the savings numbers that came from each of those and how we saw that. You know, so we cap it at a certain point so that we're not so we don't have these outliers that are, you know, some of them that are take the office, for example, where it says it's saving 95% or whatever. We would pull that out because we didn't want to have it warp the numbers significantly because one or two systems had some wacky savings numbers. So we only looked at the middle to make sure that we were looking at the savings. So inside the box is what we were looking at. And you can see this is the network lighting control savings. So the line that's in the middle with the number is the average savings for that building type. So you can see that it ranged anywhere from 28% all the way up to 59 or 68% for warehouse, for network lighting controls. So some good savings. You can see there's some really good savings in office and in warehouse. You know, healthcare had pretty good ones too, and even education, really, 41%. So next slide. And so this one is kind of where we talk about that high-end trim, right? So for all network lighting controls, and again, I emphasize the word all because this includes the luminaire level inside this one, the high-end trim average was 27%, and the others was 32%. That cut off a little bit in the slide, but it's 32%. So again, it's not additive because if you add those up, that's obviously more than 49%. But So we're seeing quite a bit of high-end trim when it comes to these network lighting control systems in there. So next slide. And then, yeah, so this just highlights that 32% for the savings from the other control strategies, right? So still pretty good numbers on average for network lighting control. Next slide. All right, so this is where I get excited. This is, for me, is the telling feature, is that if you look at LLC and you separate that out from all the non-LLCs in the network lighting controls, the average savings factor for luminaire level lighting controls is 63%, which is significantly higher than the 49% when you average all the network lighting controls. And so we're seeing a much greater energy savings with luminaire level because of the granularity and capabilities of it. So this number is we were very excited to see that this is the kind of number we were seeing with these systems. So we go to the next slide, I think we'll see the other piece of that is that high-end trim was greater in the luminaire level. It ended up being 37% and 41% for the other controlled factors. So again, much larger numbers than the ones when we look at all network lighting controls combined. And so we're seeing, and the reason for that is we're seeing that because you're able to go down to the fixture level, is that you can high-end trim the fixtures all the way down to individual fixtures or to groups of fixtures that are much smaller than you typically see in the network lighting controls, which allows for that trim to be even greater because you can trim the lights next to the window much more significant than the ones in the interior, or however that works out for even in 2 zones of control pattern for the daylighting. So you can stage it and make it so that control is very specific to the zone. Okay, next slide. And so key findings. Next one. Just again harp on network lighting controls a little bit. Is that the savings is 49% for that, which is been consistent for 3 years. And next slide. This one is, again, this is one of those ones that gets me excited, is that this shows the difference between luminaire level and network lighting controls, and it breaks it down. So when we looked at the buildings, it was a very equal split, just about 50-50 for with LLC and without LLC. And if you break that out and pull the LLC out of the network lighting control, you get the 63% that LLC saved on average, but it drops the NLC down to 35%, with all being the average of 49%. So in this, you can see that LLC sort of pulls the whole network lighting control savings strategy up quite a bit, right? 14%, and that's a lot.
Hey, Chris,
So,
could I ask?
yeah.
We're getting a question from the chat that's predominant, and where do the numbers, the source of the numbers? Could you share with us where these numbers came from? Thank you.
Sure. Yeah. So we reached out to lighting and controls manufacturers, and we reached out to customers, and we reached out to utilities, and so this data came from 194 buildings throughout the North America. So we got it directly. Typically, we got it directly from the building, from their system itself. So a lot of these network lighting control systems and luminaire level lighting control systems have a data monitoring, and they provided that data over the course of the time they've had it in, so that we could look at the data that they were getting. So we got it directly from the customers in most cases. But sometimes, depending on the manufacturer, some manufacturers have the ability to track the data as well, and we got it from the manufacturer. So it just depended a little bit on the product itself, but it came from 194 buildings across the North American area. Does that help?
Yes, that's it. Thank you.
Okay. So on this, just as a, key things to point out, high-end trim contribution, again, with LLC was pretty high, 37%, versus without LLC is only like 17%, which gives that average of 27% that we saw in the slide a few slides ago. But even if it was just the control scribes, if you took high-end trim out, which I think is still it's a huge piece of what's capable of energy savings in this. But if you said, I'm not going to use high-end trim, I'm only going to do the occupancy and daylighting and dimming piece of it, there's still a fairly significant, not quite double, but it's darn close to energy savings from LLC over just the standard network lighting control, 41 to 22%. So this is something that we've always sort of hypothesized that it was capable of. So this is a good thing for us when we saw it to validate some of our thoughts. I will say, and just like this says, is that it's always good to have more data and more information. This is relatively new, so it's good to know and have additional studies to confirm this, because we didn't have the ability to do this in the first report. But I'll show you in the next report that we have that it does confirm a lot of these numbers. So why, I just saw a question on why the trim's higher in LLC versus NLC, and from what we know, the trim's higher because of the availability of going down to each fixture level. And being able to create different zones that you don't necessarily have that capability with the network lighting controls. Because you're able to take it down granularly, you can dim it and set that trim higher. Again, like I said, as you get closer to the window, you can do individual fixtures. So like south-facing fixtures on a corner of a building, you might be able to in a normal building with network lighting controls, that would all be one zone in that corner, and they all dim based on what that one sensor sees and all raise up based on that one sensor. With every fixture having its own sensor, you can set the trim at that fixture level very easily because it's done through an app or a remote control or however the product does it. And you can set individually where that cap is based on the light level that's coming in. And in a lot of cases, that first zone might encompass 2 rows of lights that operate the exact same way in a network lighting control system. But in the LLC system, you can separate those. Even they all have that daylighting, so they meet code, but now you can separate them and they don't have to operate exactly the same. So you can create those more individual zones.
So Chris, you're answering this question as we speak, but we did have some questions also. Some people may be getting in and learning about this LLLC for the first time versus the network lighting controls. So what's the main difference between an just in short terms, the LLLC and the network lighting controls? If you could review that one more time, please.
Sure. So the biggest difference is that luminaire level lighting controls have sensors down to the fixture level, and they're installed in each fixture. A network lighting control can control individual fixtures, but they don't have a sensor in every fixture. They have it's much like it's always been, where there's a single sensor or maybe 2 sensors, right? They may put in an occupancy and a daylight sensor separately, or they may put in a combined occupancy daylight sensor that controls all of it, right? But in network lighting, that's network lighting controls. In luminaire level lighting controls, every fixture has one of those sensors in it. So you are creating a much more depth in the data that you're getting, and you're giving each fixture the ability to control itself versus controlled by a single point of access. So that's the big difference between network lighting controls and luminaire level lighting controls. And then the other thing for DLC that's the big difference is the controls persistence piece, which requires that it be capable of reverting to that energy efficient mode if it loses connectivity in any way.
Got it, Chris. Thank you.
All right, let's go on to the next one. I have to buzz through a little bit of this. This one probably only interests utilities, may not interest everybody else, but it's just that one thing that utilities use a lot of different forms to come up with what they average the time on in buildings are. So the operating time of different building types. And what we found during this report that the numbers that are being used are significantly lower than what we saw in the buildings that had these products in it. Not that it, for most doesn't mean much, but for utilities, this is an interesting thing because it changes how they do some of their math and if they decide to increase the hours versus decrease the hours. So, okay, next one. All right, so this is the next study. And so let's go to the next slide. So I think everybody here knows what a one-for-one lighting retrofit is, right? Contractor walks in, looks up, there's 12 lights, pulls 12 lights out, he puts 12 lights back in. There's, you know, that's just what they do. There's not a designer coming in, they're not moving the lights, they're not doing anything. They're just putting one in, taking one out, you know, that kind of thing. So next slide. So when we looked at this, that was one of the things that we had a question on was with luminaire level lighting controls. If I do a one-for-one, in the Northwest, we had a lot of push a few years ago for doing full lighting redesign because we wanted the most energy saving and the best lighting put into these things. Problem was they were very expensive and we weren't seeing a lot of them. So one of the questions we have is with a luminaire level, if I do a one-for-one, because I've got this granularity of sensors and I've got the ability to customize how the lights work and do, and you know, whether it's trim or, you know, how much daylighting or how much occupancy, can I get a system that is equal to a full lighting design for quality and energy savings? So we partnered up with the University of Oregon to do a study. That was a very small study. It was not a, you know, national study. It was in a building at the University of Oregon in Eugene, Oregon. And we looked at what the cost savings were, the energy savings, and the lighting quality were. Okay, next slide. So the key findings that we came from this, savings are substantial. The people that we interviewed that were working in the space, like the LLC, as much or better than the redesign, and the LLC retrofit was roughly a third of the cost of the full redesign. And the way that we did this, just so that we know, is we installed, we had one room, and we installed 4 different luminaire level lighting control systems over a period of time. Each one was in there for a period of time, and we did the study, and then we did a full redesign at the end, did the energy monitoring and the study, and that's how we came up with it. Next slide. Next one. So this was a space. It had an open office area, you know, that they created in the middle. It had cubicles at the wall where there were windows. And we had measuring devices everywhere to measure everything. So next slide. This was just a picture of each of the different systems. The baseline system was a fluorescent system, and we used a pendant mount for the space. We tested, like I said, 4 different LLC systems and 1 full redesign in the space. Next one. One of the things we did was we tried really hard to keep the systems themselves, the output, the energy use, and the quality, you know, lumens, color, temperature, all that, as close to possible as the same based on the fixtures we were able to get with each system. So you can see we ranged from 32 watts to 35.5 watts, from 3,700 lumens to 4,600 lumens. 3,500 Kelvin for the most part. One system did go to 4,000. It was a direct indirect, so almost all of them were 60-40, but one was 50-50. You know, CRI was 80 to 90, and we had 0 to 10 volt dimming. So, and each system was installed and tested sequentially in a 3-week period. I will say the last system we ran into, not that we ran into trouble, but was being done and installed at the very start of all the shutdown for COVID. So we did not get as much data on the very last system as we would have liked, but we had enough to be able to finish the report. Next slide. Commissioning and tuning, we did auto on, auto off, so vacancy and occupancy and vacancy. The timeout was 15 minutes. Daylight harvesting was set. We tuned it to the IES handbook, so 300 lux at the horizontal work plane. Just a note, high-end trim ranged from 40 to 100% depending on the measured illuminance. So like I said, the brightness of the LEDs really changed how that worked. So next slide. In this, it's probably really hard for everybody to see, but if you look at it, it kind of shows the zoning. So with the luminaire level, you can see that each fixture is its own zone when it comes to daylight harvesting and occupancy. In the network lighting controls, they followed ASHRAE, which gave for 2 daylight zones, primary and a secondary, and then the interior one was no daylighting. They were all controlled by a group of wall switches. So that was kind of the design work. So you can see sort of when you're looking at this design, how the system itself works and how each zone was put together or cluster of fixtures. Next slide. These guys measured everything, more stuff than we actually needed for what our study, but as it was a university, they went all out in their measuring and measured everything from color temperature to fidelity to gamut to humidity to solar irradiance, direct and diffused and everything. So we've got a ton of data from this over the course of the 5 months that we did this. So next slide. This is a human factor test. Everybody that worked in there took this test multiple times, answered these questions. The ones with the arrows are the ones that kind of go to quality of light and whether they liked it or not. Next slide. Here's the results. So next slide. So this is the cost. This is the one, and I'll make a couple notes on this just so that it doesn't totally freak everybody out. This was a very small space, and a lot of these systems require so a hub or some call it a WAC, a wireless access, point or a router type of thing. Those are made to control a whole lot more lights than 9 fixtures. They're made to control hundreds of fixtures. So you would be that cost of that would mitigate over if you were in a much bigger space to this space. So some of these numbers are a little high, but even regardless, the redesign was still significantly higher in cost, even if you take into account for that. Some of that comes from labor, and some of it comes from hardware, right? The majority comes from hardware and design versus the other ones. We looked at this. This is a number that we put out there just to show that there is some difference, but it's not. We're not out there claiming that a full redesign is going to cost you $18 a square foot, because that's probably not accurate. But it did. That's what it came in at with this small space. Again, as you get bigger spaces, more space, you probably see those numbers drop on all of them because of some of the economy of scale type stuff. Next slide. So this again comes down to the big energy savings. So if you look at this on the left, the first column is the total energy savings. And you can see that the redesign, that for the most part, energy savings wise, all the systems were in close proximity to what they were doing. Some of the LLC systems didn't save quite as much, but some saved more. System 2 saved significantly more than the redesign. The savings to daylight and occupancy, significantly different. I mean, that's one of the places where we saw the big energy savings. And if you look at it, you know, I want to point so that you can see, but the biggest thing is if you look at the redesign system, so the bottom line and the bottom in the core system, you got 7% in that from daylight and occupancy. And because there's no daylighting in that section, that's all occupancy was put in there. But if you look at the other 4 systems, they had energy savings significantly higher in that core space than the redesign. And that was because of the fact that not only did they have occupancy in that space, but they also had daylighting in that space. So you're starting to see that even in some core spaces that are not required by code to have daylight sensing, that there is some daylighting that shows up. It's not massive, right? Somewhere, if you think that 7% is accurate for occupancy across the board, you know, you're looking at somewhere between 8 and 17% of daylighting for that core space. But that 7 to 17% that you were never going to get any other time if you didn't have the daylighting in there from the LLC. One of the, you know, again, we see high-end trims fairly large based on the system. You know, it just, the light levels that came out of the fixtures make a big difference. Just to kind of give you an idea, the LLC system 2 and the redesign used the same exact fixture. They actually, when they redesigned it, they designed it with the same fixture. So that's why their trim numbers are fairly the same, is because they had the same type of fixture going in and had the same light levels that we had to reduce down to get it to meet those IES standards. So, but as you can see, trim's pretty big on all these, right? And it changes based on the area of space. So these were interesting findings for us. It promoted exactly the fact that we thought that, you know, energy-wise, we could save some energy. If we go to the next one, it shows, the next slide will show, I think, some of the human factors results, which was, that there wasn't a real big difference between the two, between the LLC systems and the redesign. So the occupants did not, it didn't prove that one was better than the other, but it didn't say one was worse than the other either. So they left them satisfied with all of them, satisfied with the Luminaire level version, satisfied with the network lighting control. So, again, the goal wasn't to come out and say Luminaire level is better than a full redesign, but it was basically to say that you can get equal to it for, not having to spend as much money on it, and showing that LLC does provide quality lighting and energy savings in a space. Next slide. This is when we talked to the surveyed installers, the electricians, just to show what was there. System 2 had a couple. It's got a very difficult number that shows up on the programming, and it had to do with its it an app issue that was downloaded wrong, and it caused problems, and so it's not an excuse, but it is an issue that we track, right? This is really important to us as we talk to these manufacturers, that if the programming piece is really difficult, and then it sort of turns off the people from wanting to use the LLC systems. But in the full redesign, the most difficult part was the wiring and the install of the fixtures, because of all the different work that network lighting system had to have that you didn't have to do with the Luminaire level. So next slide. Closing thoughts. For me, the LLCs are more than just lighting control. They can provide a lot of benefit to the business. And I think, if you talk to a manufacturer when they walk in and try to sell this, energy savings is probably the 10th or 12th thing they talk about. And when they do, they talk about it as helping them to pay for it. not the benefit of it. They talk about all these non-energy benefits or the business benefits that they think are going to sell it for that business. Those are what's most important for the business, and they use the energy to help, say, hey, this will help pay for it because it saves you money on your monthly bill, or you can get an incentive from your utility for it. LLCs average is saving 63%, and it's even higher in some places when it's the actual building types. High-end trim accounts for a large portion of energy savings, and I don't think that that's going away. And I also don't think a lot of people take that into account, utilities included, when they figure out their energy savings on these, because it's new enough that it's still, people are still wrapping their mind around how that works in programs. And LLCs are an easy way to get controls into a space when the lighting is changed out, and can help allow for future proofing. That's one of the big things, and I probably didn't mention it, is that because LLC is all wireless, if you decide to add a wall or take a wall out or change zones or change, scenes or whatever, it's not hard. I saw somebody ask, are they controlled basically from phones or computers? And almost all of these systems are now controlled by an app on your phone or a tablet, or they're done by a laptop. So changing and making changes are getting so that they're so easy that your facilities guys can do it, in 5 minutes, versus having to whether it's crawl up on a ladder to get into the fixture, or to do a BMS system that caused, everybody has headaches, and they've gotten to the point where it's a drag and drop slide type of thing, pretty easy. So next slide, I think.
Great job. Thank you for enlightening us on this newer technology. And I'm sure the study would be available. In fact, where can someone go to download that study? That's been, I think it was available from DLC and maybe your site as well.
Yeah. So on this last slide that's behind the poll, there's 2 links that are there, but you can go to the NEEA website, NEEA.org, NEEA.org, and look at resources and just type in LLC, and both these reports will pop up.
Okay, so
and they're free, no cards.
Yeah, that's also just in case they wanted to get more details on that. So again, I didn't say this early on. My role today is strictly, I'm a member of the Education Committee of the IES section, and we take turns in being the host. So today was my turn. So thank you, Chris, for being here, sharing some great new information for many of us. And so we invite you to come back to the Raleigh section for future sessions. Next month, we're going to have another nice topic, a focus for specifiers. So the title of that would be Writing and Holding a Lighting Specification. So we'll have some interesting focus. So Christine, any last words?
Thanks, everybody. And thanks again, Chris. And thanks, Bob, for your time today. And we will send a PDF version of the presentation, and I can add these 2 links in there for everybody. All right. Thanks so much, guys. Have a great day.
Bye, everyone.